Alright, are we recording? I believe we're recording. What is going on, everyone? Today is day 17. I'm a bit busy today. I got work, but at work I don't really do anything. So I'll probably work on a little bit more stuff at work. But anyways, today for YouTube I wanted to show you guys yesterday. By the way, shout out to support. Whoever's following, liking, means a lot to me, man, for real. Yesterday I finished what we left off on, exponential time. I know we left off on where were we? Were we right here? I think so. I don't know, but I did all this, as you can see. They want to talk about reduction to piece or something about Fibonacci sequence. I did that. Dang, I wish I really recorded this because you guys could have seen my thought process. I really locked in on this. I didn't use GPT for help. I didn't use nothing, just my pure brain. Okay, this one I did use GPT because I didn't understand what the fuck they meant by extend. So this one was a bit weird. What else did we do? Some little quiz questions on some big old complexity. And there was one last problem here. Did this by myself, which I was very proud of. Didn't look at anything. It was pretty easy. I just wanted to talk about how, for example, say the initial followers, which is N, I believe N is 10, and then the growth factor is 2, and then the days is 4. So I put initial N. I got a bit trouble with this in the beginning because of this list result thing. Every time I put a list, it would only print 20, 40, 80, 160, and I was like, how the hell am I supposed to get the initial? So I put the N in there, and the for loop goes throughout the 4 days, which multiplies the initial by the factor, and then we append the initial, the value to the list. So yeah, it runs perfect, as you guys can see. That's what I did yesterday. I had to eat, so I couldn't come back. It would have been weird, but anyways, today, obviously we're gonna finish this intro. Doesn't look that bad, I believe. I hope so. We got 2 coding stuff and some multiple choice questions, and then after we're learning about stacks. We're doing stacks. So if you guys want to give a comment down below, I was talking to my friend. He was telling me every time I finish like a certain section, I should do a leak code problem based on that section, so it's like kind of solidifies my knowledge. But what I wanted to do today, honestly, was I wanted to solidify my knowledge a little bit on give me 1 second. I want to solidify my knowledge a little bit on these sorting algorithms. So there was a lot that we just did, and I feel like he was just like, it overloaded my brain. Yeah, it kind of overloaded my brain. So I was like, fuck. But anyways, I was hoping that I could do a problem similar to each of these algorithms and kind of help me, but I'm gonna do that today by myself. Just do a couple problems on my own. So next time we move on to stacks. Yeah, it's crazy. So we're on stacks, then queues, then linked lists. These are all super important, man. All super important. I really want to lock in on these. Something I'm very curious about is after this, build a static website from scratch similar to Jacob. What is a static site generator in Python? What is that? I don't know what this does. What does a static site? A static site SSG is a software tool that processes plain text files, often written in markup languages like Markdown or restructured text, along with templates to produce a complete static website consisting of HTML. What the fudge? That's fire. I'm just gonna look at this. I'm sorry, I'm kind of like... Wow, hold up. Damn, this is kind of cool. Dang, this is pretty cool. I think we'll... Where's the website thing? So what is it supposed to look like at the end? Just curious. Oh, okay, that's pretty cool. Anyways, this is gonna be cool to make. I think I'll do this after the data structure shit that we're doing. But yeah, there's some stuff that I gotta do. After the reason why I skipped a lot of stuff and went straight to data structures is because I really want to start LeetCode and grind like crazy. So yeah, anyways, alright boys, so let's get started. I've been yapping for... Holy shit, what did I do? I've been yapping for like the last 6 minutes, so alright. Introduction to data structure. Starting with this chapter, we're going to focus on how we can store and organize data in a way that allows for even better algorithms. Data structures are just organizational tools that allow for more advanced algorithms. So, examples: stacks, last in, first out, queues, first in, first out, linked list, a chain of nodes, feature for inserts and deletes, binary trees, red black trees, hash maps, tries, and graphs. So assignment: implement the count marketers. Implement the count marketers function, right? Count marketers function. It should accept a list of strings, job titles, and return a number of users who set their title to marketer. LinkedIn users sometimes uses different cases and titles, so make sure to account for that. Okay. This is pretty easy, I think. So okay, we'll just say count is equal to 0 for titles in job titles. If titles dot lower, I believe that's how it works, dot lower, right? Is equal to marketer. We will do count plus equals 1, and then we'll return count. Alright, cool. That was pretty easy. I don't even know what this assignment was about. Sure, cool. So what are data structures? A data structure is a data organization, management, and storage format that enables efficient access and modification. Let's read that one more time, because just... You guys ever like read something and it just flies through your head? I always do that. I need to lock in. A data structure is a data organization, management, and storage format that enables efficient access and modification. A storage format that enables efficient access. More precisely, a data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. In other words, data structure stores data, organizes data so that it can easily be accessed and modified, contains algorithmic functions to expose the ability to read and modify the data. You're already familiar with some Python's built-in simple structures. List, an ordered collection of items, right? And dictionary, a collection of key/value pairs, brand, forward, model. Oh, yeah, I remember this. A data structure stored. Don't use argument. Or you know. What is not a data structure? Tuple, MySQL, dictionary, array. So array dictionary is a tuple. Could be MySQL. Okay, cool. Alright, so a list. And we're reviewing lists. Okay, we know what lists are, but from data structure and architecture, what are they good for? Let's break it down by operation. Append. Appending an element to the end of a list. Cars.append forward is on average O of 1, where you directly go to the end element, right? Index. So accessing an element in index. So cars2 is O of 1. We go directly to the index and return that element, right? Delete, removing it, so that's cars.pop. Cars.pop 2 is O of n. Okay, I deleted it down in one index. Searching for an element on the list. Cars.index forward is O of n. Anyway, so if I do cars.index forward, give me a second, guys. See, we save this here now. So if I do nums.index, was it this and then a parentheses? Yeah. I think this needs a home print returns true. Wait. Oh, it's not on the list. So I think it's because it was a string. Since it's an integer, then I'll put 0. It prints the index. Sorry. It prints the index. Brother. Stay on the page. I'm just deleting. So 0. So if we do 60, that should be 2. If I'm not mistaken. Nice. I don't think I've learned that yet. Maybe I would scroll ahead. In other words, lists start to struggle in two primary areas. We need to frequently delete elements from the middle of the list, right? We frequently search for specific elements in the entire list. Assignment. We need to display a user's last job title on the profile. Implement the last work experience function. We need to display the last. So it would be software engineer and that's project manager. Okay. Assume the list is ordered and oldest to most recent. If the list is empty, return none. So if len of work experiences is equal to 0, return none. Okay, got that out the way. So then what I'm thinking right now is the only simple way that I'm thinking is, say we say last job is equal to I don't know, none. If I do for job in work experiences, last job is equal to job, and that will return last job. Nice. Yeah, see, they did it different. I don't know if you guys understood what I did, but the thing was, it's just like, my thought process was like, okay, every time the for loop goes in, changes it till it's the last one, and the last one is the last job. I don't know if that's a fucking efficient way, but I see how they did it. If len of works is greater than 0, well, that makes sense. Comment down below which one you would do. Obviously, the right one is shorter lines. Return work experiences. The length of experiences -1. Shit. Oh no. Guess it worked. List quiz. Answer the questions based on the code from the last assignment. So, looking up an item in a list by index is much faster than searching for items using iteration O1 versus O(n). True. So, what is the big O complexity of last work experience function where n is the length of the work experiences array? If it's the length? Is that constant? How? I don't get it. What is the big O complexity of the last work experience function where n is the length of the work experiences array? Well, obviously say, okay, I guess O1. Why is index lookup so much faster than iteration? Okay, well, the index is stored in the back of the physical book, and as we all know, turning pages the computer can jump straight to the location of index, and index is an address bar. It just requires scanning up to the given location for iteration goes. I think it's this one. Yeah, that makes sense to me. So we have stacks, man. We have stack. Okay, I don't think I'm gonna do stacks on the video today, because if I move on to stacks, after I finish stacks, I'm gonna try a couple of LeetCode problems after finishing it, and then move on to queues. So the thing that I'm gonna do right now is how much do we have? We're almost there, man. Just gotta learn all this. What's P versus? Oh, this is some bullshit. I'm not learning this right now. That's for sure. Oh, BFS and DFS. Oh, these are gonna be important. These are gonna be important. Anyways, I think we're good now. Yeah, I'm gonna just finish my YouTube video off here so I can lock in on some stuff. I want to. My Git is not that good, so I want to get a bit better there, and then yeah. So hopefully you guys enjoyed this YouTube video. I know it's pretty short today. I'll try to do better than another day, but I appreciate you guys for tuning in. It means a lot to me, and yeah. I'll see you guys tomorrow. Bye, guys.